Welcome to our class. Today we are going to learn on how to resolve forces into vertical and horizontal components. And we are going to do one question to help us understand how we are going to go about it. Now, a question at hand is determine the magnitude and direction of the resultant of the following coplanar forces using the sine and cosine rule. So we're going to apply the sine and cosine rule. We have three forces, 20, 14, and 10, and the angles are indicated. So maybe you can copy the question somewhere for the purpose of reference. Now, in resolution of forces, this is a method used to determine the resultant of a number of forces. When we simply talk of resultant, we simply mean a single force that can be able to balance all the other forces in a given diagram or a system. Now, in the diagram that we have today, we have, let me put this as north, south, east, and west. We have one vector here which is acting at an angle of 45 degrees and it's of 20 newtons. Another one is inclined at 30 degrees and it's 14 newtons. And last one is inclined west to south, 50 degrees, and it's of magnitude 10 newtons as that. Now we're going to resolve these forces to a vertical and horizontal components, because our question simply tells us that we do it in sine and cosine rule. So we're gonna hear how that one comes about. Now I want us to break this down. A force of 20 newtons, when you want to get its vertical component, we're going to drop a vector here like that. This is our V. That's our vertical component. Horizontal component of that same force would act here. This would be H. So wherever I'll indicate V, I simply mean vertical and H for horizontal. So for the 14 Newton, I'll have it at this end, that is its V, and of course horizontal at the base. Same to 10 Newton force. The 10 Newton force, this would be its vertical component, and remember it's on opposite side, because if we have a number line as that, this would be to positive and to negative. So all other factors that will calculate downwards here, this would be positive, and to up front being positive. So that tells us for the vertical of the 10 Newton force, we will have it being an aspect of negative. Remember, it's acting downwards. The vertical for 14 is positive, the other one is positive. So all vertical and horizontal components in this diagram would be positive. For this case, vertical would be positive, but horizontal would be negative. For the 10 Newton force, vertical would be negative, and same as the horizontal components. Now, we're saying it a sine rule. If we remember the SOHCAHTOA method, is saying that a sine of an angle, let's say an angle theta, would be opposite equal to opposite divided by its hypotenuse. For the cosine of an angle theta, this is just a reminder, it's an adjacent over its hypotenuse. And lastly, the tan of a given angle would be equal to opposite divided by its adjacent. Now, let's use this in resolving our forces. Now, I'm going to take one force that is of 20 newtons. A force of 20 newtons. This is its vector. Like that from the center, and it's inclined 45 degrees. So its vertical would be here and horizontal. Now, for all the forces, if we want to find the vertical component, vertical component, that simply means that we will use the sine rule. So sine of angle 45 degrees should be equal to, this is now opposite. If we face it from angle 45, this would be our opposite and this would be our adjacent. Opposite and adjacent. So sine, we're going to use sine to get the horizontal component. So this is our hypotenuse. Now opposite is what we want to find, which is our vertical component, remember that, and our hypotenuse is the magnitude of this force. The magnitude of this force, it was 20 newtons, so we'll have 20 newtons here. Now our V would now be 20 sine 45 degrees. Get the value for that. 20 sine 45, if your math is correct as mine, I'm getting it as 14.14 newtons. Now we're going to do the same for all other forces. For all other forces, remember we're using the sine. Now do the same on 14 and 10 newtons. The rule is the same. So for 14, we'll simply have 14 sine, the angle is 30 degrees. 30 degrees. So 14 to the sine of 30 to give us 7.00 newtons. It's positive. Then 10 newtons sine 50 degrees. 10 sine 50 degrees. I hope you're having 7.66 newtons. So all these are the vertical components of both the forces. Now you consider in the 10 Newton force, remember it's acting downwards, so this one would be a negative. It would be a negative, so this is negative 7.66. Now let's proceed and determine the horizontal components. Horizontal components. Now horizontal component, we're going to begin with the 20 Newton force. Remember we said our horizontal is here at the base. Now for the horizontal, we're going to take cosine of an angle which is equivalent to adjacent by hypotenuse. Picking an angle of 20 like we did initially. This is 20 newtons and it's inclined at 45 degrees. We already have the vertical and now our horizontal would be here. From 45, this is our opposite side and this is still our adjacent, and this is what we want to find. Now in using the cosine, we'll have cosine of 45 degrees would be equal to adjacent, remember this, adjacent by hypotenuse, and the hypotenuse is simply the magnitude of that force, that is 20 newtons. Now we'll have our adjacent, which is our horizontal component as 20 newtons cosine of 45 degrees. So 20 cos 45, so that is 14.14. And the horizontal component for 14 Newton force is 14 newtons cos the angle is 30. Remember it will act opposite here, so it will be negative. So 14 cosine of 30, can calculate that, 30 degrees. So that is 12.12. Do the same, and it's negative, remember. So the 10 Newton force cos 50 degrees would now be equal to, just have that calculator very fast, save your time. So I'm having 6.42, and it's also a negative 6.42, and it's negative. So we'll have two factors being negative and the one for 20 newtons being positive. Remember, if this is our compass, all other numbers lying on our right hand side would be positive, on left hand side negative, up towards the north is positive, and down towards the south is negative. That's why we are having negative and negative for the 14 Newton force and 10 Newton force horizontal components. So we have all the vertical components and all the horizontal components. So all vertical components, and all horizontal, may indicate here, components of the three forces. Now in getting the resultant is, we give it R is equal to square root of all vertical components, that is summation of all vertical components, plus the sum of all horizontal components. So that tells us we need to find summation of all. So for summation of all the vertical components are 14.14 plus 7.00 plus, it was negative, so this is minus 7.66, and you get that. So if you sum up all the vertical components, we are getting 13.48 newtons. So this is positive, and that tells us it's acting upwards. Remember, it's vertical, upwards. Summation of all horizontal components, we add 14.14 plus, negative 12.12, and we're subtracting 6.42. So all this is giving us negative 4.4 newtons. I hope you are having that. So we said earlier on that resultant is the square root of vertical. Please remember, this is squared and squared. Kindly note that vertical squared, or the square of all the vertical components and square of all the horizontal components. Now our R here would now be, we are squaring 13.48 newtons plus, this is negative 4.4. So the square of the vertical components is 181.71 plus 19.36, that is the square of 4.4. So add the 2, and this would give you a square root of all of them being 201.07. So the R, your R, or rather your resultant, the resultant force that can able to balance all the three forces is of magnitude 14.18 newtons. So that is your required resultant, the magnitude of the resultant force. Now we are not done yet. We need to proceed and get the question required us to get the magnitude and direction. Now for direction, remember we've used the sine, cosine, and we are now going to use the tan. Now the tangent, or rather the tan of an angle, is given by an opposite divided by its adjacent. Please, let's look at how these angles would look like if we are putting it in a diagram. So from a point, our vertical component, which was positive, is acting upwards. So it would be something like that, of 13.48 newtons. And the horizontal components would, and the horizontal component is a negative, that's why I'm writing it in this direction of 4.4 newtons. 4.4 newtons. Now resultant is here. This is what we were doing simply when you were calculating, and that's why you are having it in form of a triangle. So the hypotenuse here was simply the square of the vertical and horizontal. Now in calculating, or rather finding the direction, our angle theta would be here. That is our angle theta. So a tangent if this is our theta, remember this would be our positive, not this opposite, and this is the adjacent. Now, tan theta, an angle that we want to find, is now equal to 13.48, and remember it's in newtons, divided by 4.4 newtons. So remember it's a ratio of two forces, and that's why you get a pure number. So this would be a tan inverse of an angle, tan inverse of would simply be 71.9 degrees. So this is the direction of your resultant force. Direction of your resultant force. Let's make sure you're indicating degrees because it was a magnitude of two forces.